am here to continue from where we left the last time. My today's plan is to first take everyone through an exercise. This exercise is in relation to the topic we discussed in our last session, that is computational thinking. So before I start, just to brush up, computational thinking is the thought process involved in formulating a problem and expressing its solution in a computer or human understandable form. So let's move on to our exercise. As you can see on your screen, the first exercise is a filling the blanks. The first question is, which of these is not an example of a loop? So what is a loop? A loop is a repetition. Any repetition is called a loop. So if you see the options, option A is move your neck from right to left. Option B, move your hand from left to right 10 times. C, repeat the following steps till someone tells you to stop. That is, fill water from the basin, walk to the garden, water the plants, go back to the basin. And the fourth option is, I guess only 3 options are there. So what do you feel? Which option is not a loop? If you can see, B and C is a loop wherein there is a repetition of an action. So A, that is move your neck from right to left, is the answer. The first answer is A. As I have highlighted it, you can write it as A is the answer. Second question. Let's move on to our second question. That is, dash gives us a clear picture of what output we want. I'll repeat. Dash gives us a clear picture of what output we want. The answer is abstraction. Abstraction gives us a clear picture of what output we want. Third, dash is a thought process involved in formulating a problem and expressing its solution. I know everyone will be knowing the answer, that is, computational thinking is a thought process involved in formulating a problem and expressing its solution. The fourth, filling the blanks, is a pattern matching problem, and I know it's a logical problem and you all will know how to solve this. So if you can see here, 1, 4, 9, 16, 25, 36, dash and 64. So if you can see, you have to identify the pattern in the numbers. The pattern here is 1 is 1 square, 4, 2 square is equal to 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36 and 7 square is 49, and that is your answer. 64 is 8 square. So this is the way how you find out the pattern in a question or a problem and finding the solution according to the pattern formed. Let's move on to the next question. Question B, that is question and answers. So I'll just explain you what the question is and the solution. You need to write it in your book. Question 1. Write an algorithm to draw a rectangle. Modify the algorithm to give instructions for a square. So here I have given you the solution. So for drawing a rectangle, the algorithm is, any algorithm starts with a start and ends with a stop. So the first step of the algorithm will be start. Second step is draw a horizontal line of 10 centimeter. Third step, turn 90 degree to right side. Fourth step is move 5 centimeter vertical. As it's a rectangle, you need to provide the breadth and length accordingly. Then fifth step is turn 90 degree to right side. Then repeat the steps 2, 3, 4 once and then stop. This is the way you draw a rectangle. Similarly, you need to write an algorithm to draw a square wherein the sides will be same. As you know, a square, all the sides are same. Accordingly, I would like everyone to write it by yourself. Second question is, what is the meaning of loop? Explain with an example. I have given you the answer here. So a loop is a sequence of instructions that is repeated until a certain condition is reached. For example, if we want to display numbers from 1 to 100, the first step is to set the variable value as 1 and then display it 100 times, increasing its value by 1 on each loop iteration. As you can see on your screen how the loop can be written. Here I have used while loop. So you can see the initialization, the condition to be met and the iteration that is increased by 1. Question number 3. Look at the pairs of the items given below and write 1 or 2 similar things about them and 1 or 2 different things. So here we are going to see the similarities and differences of the two things. First is aeroplane and bird. The similarities among them is both can fly. Second is they have wings. The difference is aeroplane is a non-living thing whereas bird is a living thing. Second difference, aeroplane carry people whereas bird cannot. The second pair is pencil and pen. Similarity is they are used for writing. Both write on paper. Difference is pencil has lead whereas pen has ink. Anything written by pen can be erased whereas pen ink cannot be erased. The third pair is alligator and fish. Similarity between them, both can swim in water. Second, both are cold-blooded creatures. That is, they take on temperature of their surroundings. Difference. Alligator is an amphibian, that is, can stay on land and water both, whereas fish lives inside water only. Second, alligator doesn't have fins, whereas fish has fins to swim. We are at the end of the exercise. Hope you all enjoyed it. Now, let's move on to the new topic, that is Sudoku, which is a part of computational thinking itself. Many of you must have heard this word, Sudoku. It is a puzzle and many of you must have tried it, which comes in your NIE newspaper. If not, today we are going to learn how to solve this puzzle. It's a very interesting game which you all will love to do. So let's see what the Sudoku is. Sudoku is a Japanese number puzzle. It is an excellent tool to improve logical thinking, concentration, and reasoning. It doesn't require a math skill. In Sudoku, there can be 4:4, 6:6, or 9:9 grid. And the goal is to find the right placement for the numbers 1 to 9 in each row, each column, and the grid. As you can see here, there is 4x4 mini grid wherein there are 16 blocks. This is a mini grid wherein there are 4 boxes where you need to fill 1, 2, 3, 4 as each row, each column and grid should have only once the number. Let's see a video which will help you to understand Sudoku in a better way.
A mini Sudoku 4x4 consists of a grid with 16 cells. Some cells already contain a digit, possibly from 1 to 4, while the others are empty. Here is an example of a puzzle. The grid can be divided in 4 rows, four columns,
1, 2, 3, and 4.
and 4 boxes.
1, 2, mini grid, 4th mini, 3rd mini grid, and 4th mini grid.
The rules of the game are simple. Fill in the empty cells with the digit from 1 to 4, making sure that each digit is present only once per row, once per column, and once per box. Here is the previous puzzle once completed. You can check that all the digits from 1 to 4 appear once on each row, each column,
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4.
and each box.
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4.
Our techniques to solve Sudoku puzzles come from the rules. We are checking, by using logic, where we can't or where we should input a digit in the grid. One easy case is when a cell is the last empty cell in a row, in a column, or in a box. Here is an example of a last empty cell in a row. 3 digits are already present in the 3rd row. There is only 1 empty cell. The missing digit, 2, can fill in the empty cell. Here is an example of a last empty cell in a column. 3 digits are already present in the 4th column. There is only 1 empty cell. The missing digit, 1, can fill in the empty cell. Here is an example of a last empty cell in a box. 3 digits are already present in the bottom left box. There is only 1 empty cell. The missing digit, 3, can fill in the empty cell. Only 1 possible cell in a box for a digit. With this technique, we are going to draw an imaginary line over the cells of a box where we are not allowed to enter a specific digit. We then check visually if there is only 1 possible cell left in the box for this digit. If that is the case, we can put the digit in the cell. In this example, we consider the top right box. It doesn't contain the digit 1. A digit 1 is present in a row intersecting our box, so we can't enter another 1 on the same row as the digit is allowed only once per row. We draw a line in our mind from this 1 over the row through the top right box. This line covers the cells where it is not allowed to enter 1. We can see that there is only one empty cell in this box where we can input a 1. As it is the only possibility, it is where we enter 1. In the next example, there is something similar with an intersecting column. We consider the same box. It doesn't contain the digit 2. A digit 2 is present in a column intersecting our box, so we can't enter another 2 on the same column as the digit is only allowed once per column. We draw a line in our mind from this 2 over the column through the top right box. This line covers the cells where it is not allowed to enter 2. We can see that there is only one empty cell in this box where we can input a 2. In the next example, there is something similar, with both on an intersecting row and an intersecting column. We consider the top left box. It doesn't contain any digit. There is a 4 in an intersecting row and another 4 in an intersecting column. So we can't enter another 4 on the same column and row. We draw a line from these 4s over the row and the column through the top left box. These two lines cover the cells where it is not allowed to enter 4. There is only one empty cell in this top left box where we can input a 4. In the following example, while we have an intersecting digit over a box, it is not enough to reach a conclusion and input a digit. We consider the bottom right box. It contains only the digit 1. There is a 2 in the intersecting row, so we can't enter another 2 on the same row. We draw a line from this 2 over the row through the box. This line covers the cells where it is not allowed to enter 2. We can see that there are 2 empty cells in this box where we could input a 2, not just 1. There is no way to know currently where to enter the 2 in this box, so we do nothing for now. We'll have to try something else. We check another digit or box. There is no mandatory order to apply these techniques. Whenever you notice a last empty cell in a box, in a row, or in a column, enter directly the missing digit. For each box with empty cells and each digit not present in the box, try the only possible cell in a box for a digit technique. To review these techniques,
these were some beautiful examples which was taught to you mainly through mini Sudoku for the kids. There's one more video which will tell you how to solve a Sudoku in a much better and simpler way. Let's see the video.
Sudoku puzzles can look intimidating, but you don't have to be good at maths to do a Sudoku. By focusing on step-by-step elimination, you can finish a Sudoku in minutes. Here's a puzzle.
Earlier, it was a 4x4 Sudoku which was easier. Now, we are going to see a video of 9x9 grid Sudoku wherein some easy step-by-step guide will help us to fill a 9x9 Sudoku easily. Let's look on to the video.
Before you know it, it'll be solved. There is no specific place to start a Sudoku. It's really up to you. The most crucial thing to remember with a Sudoku is the golden rule. Each row, column, and smaller 3x3 box contains all the numbers from 1 to 9 and only once. And of course, this means that no number appears twice in any row, column, or 3x3 box. All of our problem solving springs from this simple rule. Okay, let's get started. We know that each 3x3 box must contain all of the numbers, and the top middle 3x3 is missing a 1. There is a 1 in the second row down and a 1 in the third row, and because these rows cannot contain another 1, you can see that the 1 has to be in the top row. We already have a 2 in the middle square of that area, and there is a 1 in the 6th column, so the new 1 can't be in that column. So the 1 to be added must be in the 4th column from the left. There, we've added our first number already. Let's do another, using this number 2. No other 2 can be added to that column, and there is a 2 in the 4th column, so the 2 to be added to the bottom middle 3x3 box can't be in the left or the middle column, it must be in the right column. We already have a 5 in there, and there's a 2 in the row 1 up from the bottom, so the new 2 must be in the bottom right corner. Using the same logic, you can see where to place the 3 in the top middle 3x3 box. These 3's show that it can't be in the top 2 rows, and the 3 here that it can't be in the middle column, so it must be in the bottom right corner of that box. When doing a Sudoku, there is no proper order for continuing. You can try to do all of a particular number, or perhaps scan groups of 3x3 boxes to spot quick wins. Let's see this for adding a 4 to the bottom right 3x3 box.
So, similarly, you can move ahead and complete your Sudoku, that is 9x9 Sudoku, taking up any number in any pattern in any way. I am putting the links of these Sudoku YouTube links in the exercise word file. You can go through it again if you need so. There is even a link called Sudoku generator, that is sudokuweb.org, wherein you can generate Sudokus and play it as and when you need it. It is a beautiful site wherein you can select any 9x9 or a 6x6 or a 4x4 Sudoku, and you can play accordingly. Just to have a good hand on Sudoku, you can go through this link. The link has been given to you. You can go through, generate the Sudoku and play along. To recap, I would say the golden rule once more. Each row, each column and the mini grid should contain all the numbers. If it's 9x9, from 1 to 9. If it's 4x4, from 1 to 4. And only once. The rule is simple. Fill in the empty cells with a digit from 1 to 4 or 1 to 9 respectively, 9x9 or 4 to 4. Each digit is present once per row, once per column and once per box. In our exercise word file, I am putting few Sudoku examples which are there in our books. I will kindly request every one of you to solve this, and it will be checked once the schools are open. So this one will be one and this is the other one. So it's a request that everyone will solve all the examples which has been given to you. So for now I am just taking a leave and hope to see you soon with a new topic. Stay home, stay safe. Thank you.